Hello, I'm Tony Svejcar with the Agricultural Research Service, and I'm here to present an Eastern Oregon Ag Minute. This week I'm going to cover atmospheric carbon dioxide, or CO2, and carbon credits. I'm sure by now just about everyone has heard the term climate change, and there are strong opinions on either side of this topic. The argument is over the relationships between atmospheric CO2 and warming. Does CO2 trap long-wave radiation and increase temperatures? This is referred to as the greenhouse effect. The debate has been over the link between atmospheric CO2 and temperature. However, I don't think there's much argument over whether atmospheric CO2 is increasing or not. There's really good documentation that atmospheric CO2 has been rising for a long time. Keep in mind that yearly global consumption of oil, although it declined this past year for the first time since '83, it's still over 31 billion barrels of oil. I'll repeat that number, as globally we consume 31 billion barrels of oil each year. So one byproduct of burning oil is CO2. Just what does this do for atmospheric CO2 levels? I'll talk about that tomorrow. This week I'm talking about atmospheric CO2 and carbon credits, which will eventually impact agriculture. Today I wanted to give you all a feel for what atmospheric CO2 is and what its trends have been. CO2 is a trace gas, which means it occurs at very low levels in the atmosphere. Currently the level is 0.038%. When we get concentrations this low, we usually express them in parts per million. So current CO2 levels, we would call it 380 parts per million. Up until the year 1800, CO2 levels had been fairly constant at about 280 parts per million. Levels started creeping up, but were still only 310 in 1960. So to kind of summarize that, at 1800 they were 280 parts per million, 1960 went to 310, and currently at 380. So from 1960 to present, we've seen a fairly constant increase from year to year. I've measured photosynthesis in plants for over 24 years, and as part of that, we measure CO2 levels. When I started in 1983, atmospheric CO2 was right at 330 parts per million, and now it's at 380. So that's a 15% increase. The trend is definitely up, and I'm not sure why that would change in the near future at least. Tomorrow I'll talk about how plants fit into the whole CO2 picture. Today I'm going to talk about the role of plants in the carbon cycle and how they might influence atmospheric CO2. Plants have the unique ability to use energy and sunlight and create carbohydrates using CO2 as the building blocks. Without this process, there would be no higher life on Earth. So photosynthesis and the presence of atmospheric CO2 really keep us all going. When plants take in CO2, it can end up in a variety of places. In the crops that we eat, the forage that we feed our animals, the wood that we build our houses with, or in the organic matter in the soil. The point is that plants have the ability to take CO2 out of the atmosphere and store it in a variety of forms. The net effect is to actually reduce atmospheric CO2 to a level lower than it would have been without the plant. Now the levels are going up because of burning of fossil fuels, but the plants really do take in enough CO2 to keep that level from going up as much as it might otherwise. Now keep in mind that plants also respire and give off some CO2, but they generally take in more CO2 than they give off. And there are things that we can do in agriculture and forestry to help increase carbon dioxide storage by plants. There are programs in place and under development which will provide incentives for increasing CO2 uptake or reducing losses. More on that tomorrow. Today I will briefly talk about the Chicago Climate Exchange and their Rangeland Soil Carbon Management Program. This program is aimed at providing payments for carbon credits to ranchers who apply management which is likely to increase soil carbon. There's one difficulty with this and almost all other agricultural carbon credit programs. The cost of measuring soil carbon is higher than the value of the carbon. Let me repeat that. The cost of measuring the change in soil carbon is greater than the actual value of the carbon. This is where research was valuable. We were able to convince the Chicago Climate Exchange that we had adequate data to put numbers on the amount of carbon we could expect to store under several different scenarios. There was a committee of about a half dozen folks who helped set up this program. And I can tell you from being a member of that committee, it's not easy to develop a broad, general program that covers basically the whole country. We had to select large land resource areas based on productivity and available data. I hate to admit it, but Harney County is, because it's grouped with arid parts of Nevada, dry parts of Nevada, we're not eligible, whereas the counties to the north of us are. Now I'll try and work on that. If you want more information, look up the Chicago Climate Exchange on the web or give me a call. This week I've been talking about atmospheric CO2 and carbon credits. Now, these are pretty complicated topics, and it's a little hard to cover them in a minute and a half or 2 minutes on the radio. But to summarize the high points, atmospheric CO2 is increasing, and how that will influence climate is under debate. There's not a complete agreement on that. But there is concern over increasing atmospheric CO2, and that has led to carbon credit programs such as those on the Chicago Climate Exchange. The idea is to encourage forestry and agricultural practices which maximize carbon storage. One of the problems on rangeland is that we have pretty low storage rates, so it takes lots of acres to come up with a reasonable contract. At the moment, Harney County is not eligible for the Chicago Climate Exchange program, but I hope to see that change. It's unlikely that concerns over increasing CO2 will go away, and I would expect to see more emphasis on programs of these types in the future. The good news is that many of the practices that are good rangeland management also maximize photosynthesis and carbon storage and really serve as the basis for this carbon credit program.